Okay, you guys is smart kids. You guys recognize that if I draw a triangle here with A, B, and C, you know that if I have a red theta or I have a green theta, that I can use tangent with the legs, yes? Which means that you can use the ratios involved in comparing the opposites and adjacents, yes? The opposites and adjacents always being the legs of a triangle. But being the smart kids you are aware that it is not a triangle if it only has opposite and adjacent, is it? A triangle has a third side, the hypotenuse. And you guys are smart kids. If the opposites and the adjacents change in proportion to each other, then what must happen to the hypotenuse? Does it too change in proportion? Yes, of course it does. Which means ratios involving the hypotenuse must also work. Yes? And we are going to today deal with those other two ratios. The first one that we are going to talk about is the sine ratio, which on your calculator is the sin button. Naughty. Don't worry, it's fine. So, we are going to be using that button. Now, you guys need to pay attention. Tan is opposite and adjacent. Sine compares the opposite to the hypotenuse. And I'm only going to write hype because I'm lazy. Okay. Now remember, what is key? How do you decide where opposite is? Opposite means what? Means, not mes. Opposite means across from what? From your. Please highlight your. From your theta. Opposite is across. Whatever you decide theta is, the opposite measurement is the one that is across the triangle. Everybody good? Just like in tan. You guys being the smart kids that you are, cosine ratio uses what button? Cos. And what must it compare? I've done opposite adjacent, opposite hypotenuse. What must cos be? Adjacent. Connor? Adjacent and yes. Adjacent to the hypotenuse. Now this one causes kids trouble. Put a few stars by it. Because we already know adjacent means what? Adjacent means beside, right? Except think about a triangle. A, B. So what letter would I write right here if I was labeling this triangle correctly? Little a. And what letter would I put right here? Lil B. And what letter would I put right there? Lil C. So we can all easily recognize the opposite because it's across the triangle, right? But when I say adjacent means beside, then kids get into trouble because they come to their theta right here and they say, well, there's two things that are beside it, Mr. Myers. One of those things is what? The hypotenuse. Does the hypotenuse ever change? No. Means beside. And this is anticlimactic because my computer's frozen. But not the hypotenuse. Cool? Yeah. All right. That sets up this handy-dandy pretend word. SOHCAHTOA. Sine. Op. Hype. Cos. Adj. Hype. Tan. Op. Adj. And what does it mean? The sine of theta equals opposite over hypotenuse. The cos of theta equals adjacent over hypotenuse. And the tan of theta, that should be green, but my computer is lame and doesn't work right. Tan of theta equals opposite over adjacent. Now you should have some blank space here, yes, unless you wrote gigantically. Everybody on the left, draw a triangle. Label it thusly. Label the sides correctly. A, B, C. And then tell me, using the letters, tell me the sine of A, the cos of A, and the tan of A. Only using letters. Go. Then, of course, when that's done, I want you to do the same thing with the sine of B, the cos of B, and the tan of B. And then you're going to notice something. What is the sine of A? A over C. What is the cos of A? B over C. And what is the tan of A? A over B. Now, what is the cos of B? Sine of B. B over C. What is the cos of B?
B over C.
Cos of B.
Oh yeah, A over C.
And tan of B.
A over B.
Tan of B. B over A. What is it that you are noticing about the sine of A and the cos of B? And the cos of A and the sine of B? You should be noticing something. They're the same. The sine of one is the cos of the other. Everybody cool?
Yep.
Does everybody, and I know this seems simple, and I know it seems odd that I'm spending this much time right here. Does everybody understand this? Okay. Would this chart change, this chart here, would it change if I put numbers here? What would it be? What would the sign be if this was 5 and that was 7? What would I write there? Oh, wait, sorry. Not 5 and 7. Sorry, I'm an idiot. If it was 6 and 8.
For sine
Yep.
of A.
Yeah, for sine of A. What would you need to do before you could even tell me the sign? Pythagoras. 36 and 64 is 100. Square root of 100 is 10. Excellent. So now, what would the sign of A be?
A or 6 over 10.
6 over 10. What would the sign of B be? 8 over 10. What would the cos of A be? 8 over 10. What would the cos of B be? 6 over 10. What would the tan of A be?
6 over 8.
And the tan of B? I know it just went out. Just tell me. 8 over 6. Does everybody get it? So, that thing that kids do when they tell me, I can't do it when it's not the letters, or I can't do it if it's got different numbers, is horsepucky, isn't it?
Yes.
Excellent. Now, let's look at this question. 7. This example. What did I tell you you need to do every single time, and then you can't possibly screw up trig? Show your work. Do I have a theta?
12.
12. Which means, of course, this is the angle where I am living, yes? Which means that is the angle from which I choose my opposites and adjacents. Does everybody understand that?
Yep.
Great. So, if I am there, what parts of the triangle do I have at my disposal? I have an hypotenuse of what?
25.
And I have what else?
Adjacent.
No.
Or opposite, sorry.
I have an opposite that I need to find. Which of the three uses O and H? Sine. So I now write sine of theta equals O over H. Do I need to write this step every time? This one? No, because as you get better, you're not going to need it. Now you fill that in. Sine, what's theta?
12.
12. What's O?
Uh,
X. What's H? 25. What algebra finds that? Multiply or divide? Multiply, because you're trying to get rid of this denominator. So it's going to be... Now, for these warm-up questions, I'm actually going to write it out. Cancel, cancel. 25 sine 12 equals X. Now, can I tell you what to do here anymore? Why not? Because everyone's got a different calculator. Now it's your job. How does your machine tell you this answer? And I will take answers to 1 decimal place. What is it?
5.3.
5.2. Can everybody do this? Great. Let's try the next one. I feel like writing in dark green. Do I have a theta?
Yeah.
What is it?
19.
19. What other parts of the triangle are available to me? I need a hypotenuse, which is X, and I have an adjacent, which is 40. Now it's decision time. What uses A and H? Cos theta is A over H. Fill it in. What's theta? 19. What's A? 40. What's H? X. Now, algebraically speaking, we went over this a whole bunch, right? So much so that you should all be able to recognize that 40 divided by cos 19 equals x. Yes? Okay. Now, remember, you have to know how your machine does this. These ones are particularly tricky, especially if you have a backwards calculator. Because if you punch 19 cos, your screen is going to fill up with numbers. And some of you are going to stop. What haven't you pushed? You must push equals at the end of it if you have a backwards calculator. So what is your answer? Who has an answer for me? To one decimal place. Connor. 42.3. Now, I'm going to stop you for a second there and ask you if both of these answers make sense. Is this an hypotenuse or a leg?
Leg.
A leg. So it must be what? Smaller than the hypotenuse. Is it?
Yeah.
Yes. Would you ever base that assumption on what the drawing looked like? No. What is this? The hypotenuse. Is this a small angle? Yeah, 45 is halfway, so that's like there, right? So knowing that that's 20 degrees, you know this has to be very short, yes? Which means this must be very long, close to the hypotenuse. What if this number was less than 40? Would you write it down? Of course not, because why? Because an hypotenuse must be the longest side. Does everybody understand? Yep. This is where that it takes 20 steps to walk the length of Vancouver Island comes back again, right? You don't do work and submit it to me when it makes no sense. Because just like your grade 9 textbook says, math makes sense. It has to, or we can't do anything. So everybody look at, I feel like writing in orange over here. Do I have a theta? No. What other parts of the triangle do I have? I have an hypotenuse of what value? 22, and an adjacent of 13. What uses A and H? We know it to be cos, but this question is different. Why? Because I'm looking for an angle, so it must be shift cos. Shift cos of theta equals 13 over 22. Make your calculator do that. And remember, do we do decimal points with degrees? No. So what do we round the degrees off to? Unless otherwise instructed. Whole number. So how big is theta? 54 degrees. Can everybody do the theory? Now, please listen to me. Theory is not real world. You cannot work in the real world, though, if you do not understand the theory. Okay? How many of you guys have seen those dudes, and I don't mean to be sexist, but it's almost always dudes, standing around a construction site, looking through a telescope at another dude way far away, and there's a laser beam involved? You have seen those dudes, yes? Guess what they are doing? grade 10 trigonometry. And they are being paid tens of thousands of dollars for that job. So when you say to me, Mr. Myers, when am I ever going to use this in real life? I will say, if you choose to go out and earn tens of thousands of dollars by doing this, you can even pretend to be a pirate. You can cover your other eye and make a hook and look through the telescope and go in your head, yar, while you write down and do grade 10 trig. Okay? That is all for me. Page 95. All the answers are there.
59.
Well, it's titled page 95. This is the problem, right? On your outline, it will say page 95. See? And I don't know if I put page 101 in your guys's or not. I did? So you're doing 95 and 101 right now. Now, please notice that there's nothing more for me to teach you with trig, is there?
Nope.
All we can do is practice it because that's all there is to it. Those three fractions. So you guys are going to start working on 95 and 101, which in your books are page, 59 and 60. Tomorrow, we are going to do something real life. Okay? I'm even going to let you leave the room. But to do what I'm going to ask you to do tomorrow. But of course, I'm going to send an email out to all the teachers that says if they find anybody of a middling sort of age being disruptive outside of this classroom, I would recommend continuing to walk. Do you understand?
Yes.
Good. Go. I will be walking around assisting as needed.